Assessment 9.7 asks us to give the mechanism of the reaction of an alkene with bromine. This is going to produce a racemic mixture. We'll only show the mechanism of the formation of one enantiomer. The reaction is going to start by the pi bond attacking the bromine, kicking out Br-, while at the same time a lone pair on bromine comes back and attacks the carbon that lost its pi bond. This is going to give us a bromonium ion, which, as I said a second ago, could form on either the top or the bottom. That's why we're going to get a racemic mixture, but we're going to show it as if it has added only on the top. In truth, it will add to both sides. The byproduct of this reaction is Br-, which is now going to react with the electrophilic bromonium ion. That Br- is going to attack at the most substituted carbon of the bromonium ion, pushing the electrons in the carbon-bromine bond onto bromine. Now, because this bromonium is on the top face of the molecule, that Br- is going to add from the back. And so the one enantiomer whose formation we're rationalizing with this mechanism will be the one that has the bromine back at this carbon and the bromine forward at this carbon. That tert-butyl group that was originally on a dash bond pointing back is now going to be pushed forward. The key for the addition of Br2 and in terms of the stereospecificity of this mechanism is that we end up with the two bromides on opposite sides. So we end up with a trans-dibromide arising from anti-addition. That anti-addition is because the face that we have formed the bromonium ion is attacked on the opposite side by the nucleophile that adds.